So, hello everyone. We are back to our class, and in this class, what will be starting AC breakdown mechanism. But before that, let me recapitulate a little bit about the previous class, what we are doing there, and we should finish a little bit of that which was left. So, what is that? We are starting the this discharge patterns in glow discharge. So there are dark and bright bands which are seen in glow discharge, and we are trying to understand what are they and how they are formed. So we told that there are Aston dark space and cathode glow layer and Crookes dark space. They appeared because just immediately after the emission, the electrons form a layer just adjacent to the cathode, and a seed of electrons are formed there, and they are not very highly energetic and not able to excite the atoms, and they are rather retarded because of the seed of the electrons that has been formed. So they are forming a dark space adjacent to the cathode, and that is called Aston dark space. After that, they are getting accelerated gradually in the field, and they are trying to move towards the anode, and on the way they meet some of the ions which were moving towards the your cathode. So when they combine, they emit some light, they release the energy, and that part glows, and we call that as cathode glow layer. And after that, the electrons gain more and more energy, whichever was left. So that time their energy is so high that they cannot be captured by the ions which are moving towards the cathode. So again a dark space forms because they are not interacting with the atoms which are there, so they are not exciting them to emit the light. So you see a dark space that is called Crookes dark space. After that, what is happening, once the electrons gain sufficient energy because they are anyway getting accelerated towards the anode, so inelastic collisions of the electrons start, and they result in the excitation of the ions and formation of brightest region in the discharge called the negative glow. So what they are doing, they are now causing inelastic collision, making ionization, and forming the excited ions which are emitting the light. So that is why you see a very bright zone, that is a negative glow. And since the electrons lose their energy after the inelastic collision, so after the anode glow, you see a dark space, and that is called the Faraday dark space. And after this region, the number of electrons are increasing more and more as they, because they are ionizing. Maybe their energy is reducing, increasing, reducing, but their number is increasing. So after the Faraday dark space, they are so huge in number, and some of them are definitely making a collision, and which are ionizing. So the ionization that is produced because of that is huge, and that meets the all properties of plasma, and depending on the pressure, length, and diameter of the tube, this part looks either steady or made of very successive dark and bright bands, and this is called the positive column, and this extends till the your anode. So this zone is called the positive column. Now in a discharge tube, if you increase the pressure of the gas, then this positive column gradually increases, and the dark and bright band basically get squeezed towards the cathode zone, and at sufficient pressure, say about 100 torr, this all the dark and bright bands near the cathode sinks, and the positive column almost fills the whole space. In such situation, of course, the positive column contact radially. In such situation, the plasma so produced is called the glow discharge plasma, and color of the luminous positive column, which has extended till the cathode, even from anode to cathode. So that now bears a emission of characteristic wavelength. For example, if you fill it with a neon, you will see the neon's red glow, and if you fill with something other, you will get the characteristic line or color of that plasma which you have filled in. Okay. So on the right hand side of each slide, I have just put the different layers. So cathode, then Aston dark space, then cathode glow layer, then Crookes dark space, negative glow, Faraday dark space, and then the positive column. And this is the the column which is of interest in lighting. And as you increase pressure, as I have told you, around 100 torr, this region, positive column, extends till almost the cathode, and this fills the whole space, and it is an excellent light source for all of us. Okay. So with this, actually, now I enter into the AC breakdown mechanism. So which is the basically topic for this class. Now, to understand that, we remember that we have already studied the your DC breakdown mechanism. So there, what we have heard, we have learned that this fast chain breakdown mechanism is there, and to get a breakdown happen, you need to have a minimum breakdown voltage for a given gap, okay, at a given pressure. So for PD, you have seen that the breakdown voltage varies very non-linearly, and you have a minimum breakdown voltage corresponding to some PD. Okay. So with this, we now switch to the AC breakdown mechanism. Unlike your DC, where there is a cathode at certain polarity and anode at certain polarity, here what is happening, that the polarity of both the electrodes are switching. So once it is positive, the next time it is negative. So what is our purpose? That one electron will be emitted from this one electrode. For example, suppose it is now cathode, and that electron, as it proceeds towards the other electrode, it forms an electron cloud. Why I have shown it in the form of a cone? Because 1 to 2, 2 to 4, 4 to say 8, like that, actually they are multiplying. So they are multiplying, and when they reach the anode, they should be infinite for the breakdown to happen. And once such things happen, you get the plasma formed within this tube. Okay. So now what I am doing here, I am now applying an electric field of the type E equal to E0 cos omega t. I have plotted over here, but just seeing at the this axis, and you may you may be mistaken that this is a sine curve, but is actually this is a cosine curve, because I have put the t equal to 0 over here. So this is maximum over here. So this is actually cosine curve at 0. This is the maximum. Okay, and you know the period how it is. So this is the half period, and if you put it in terms of omega t, then this is pi by 2, this is pi, this is 3 pi by 2. So remember this configuration, and we are applying this electric field across these electrodes. Okay. So an electron which enters the left end of the discharge tube moves towards the anode driven by the field, and in doing so, it multiplies. It goes on multiplying the electrons through ionization as it travels through the gas. Okay. So a trail of positively charged ion is created on its path. Why I am saying that there is a trail of positively charged ion? This is because once the ionization takes place, then the electrons which are liberated from that, they get quickly collected by the right electrode. For example, they will be always collected by the positive electrons. So the mobility of the electrons are so high compared to the mobility of the ions, that the moment they are created, almost immediately they get collected. So what is remain? The bulky ions, because they cannot move so fast. So but they respond to the electric field, of course. But you will see that once the breakdown takes place, for example, suppose we are using this field, and this only gives you the breakdown. This is the field which is just sufficient to make the breakdown. So the moment the field crosses this region, the field is not good enough to make another breakdown. The ions are created, and they are left like that, and whatever the electrons they are that time created, they get collected by the positive electrode, which is that time existing, because in an AC field the electrodes are alternating their polarities. Okay. So we have an electric field E equal to E0 cos omega t. Now we come to this. For an AC field, the direction and magnitude of the electric field varies with time. As I had told you actually. In 50 hertz, AC supply, which is in India with us, the time between polarity reversal is, half the time period. So it is around 10 millisecond. Okay. So it is 50 hertz. So T by 2. So you get this thing. Now, the complete breakdown process takes place within a time less than a microsecond. Okay. So polarity reversal is occurring at a much higher time scale. Therefore, the alternating nature of the field in this case will not be able to interrupt the breakdown process for most of the time. Hence, for low frequency fields, the breakdown process will be very much similar to the breakdown mechanism which we have observed in case of DC breakdown. So, as the frequency increases, the scenario will change. Why? Because you know that at sufficiently low frequency, the these ions may not travel very the travel may respond to the electric field when the your field is frequency is slow. Uh, then what will happen? This breakdown will be almost similar to the DC breakdown mechanism, because electrons are getting collected, then ions are moving. So similar to the DC breakdown case. But when the frequency is high enough, it may happen that before they get collected by one electrode, the field is switching. So before they are completely collected by one electrode, the charge distribution, for example, the ion distribution, they were traveling in one direction because they are slow, they could not get completely collected. Before they get completely collected, the electric field is reversing its polarity. So in that case, what is happening? Some charge is always staying inside the discharge tube. So for that case, actually, some charge is residing within the tube, so that will create some electric field. Now, at this point, I would like to make you remember that that electric field produced by charged particle, we all know Coulomb's law. It is 1 by 4 pi epsilon 0 q by r square, where r is the distance. Now, you understand that one charged particle is producing that electric field. Now, you apply the superposition principle, and there are number of charged particles which is of the order of 10 to the power 20, 10 to the power 19, 10 to the power 21 kind of thing. So, when such huge number of charged particles, the field adds up, that becomes substantially high, and that will be over and above the electric field which you have applied externally. So, that will assist the breakdown mechanism. So, that is how, if you are going for the AC field, because of the accumulation of charge, basically because of the accumulation of charge within the tube due to non-clearance of the charge in one cycle, the accumulation happens, and that affects the discharge mechanism through the addition or subtraction of the electric fields. So that is how, and in what way it affects your discharge mechanism, we will understand in this AC breakdown class, and we will try to formulate those things mathematically, and we will proceed like this. So as I told you, we have this electric field equal to E0 cos omega t, and at t equal to 0 it is maximum. So we assume that the breakdown happens when t equal to 0. Okay. Now, once the breakdown has happened, as I told you, the electrons get very quickly collected. Now, what is happening, after the electrons are collected, the ions are moving towards the negative polarity electron. So, they are moving and moving and moving. How long it will move? It will move up to omega t equal to pi by 2, because after that what is happening? The field is reversing its direction. So, If it is not collected at this point, then what will happen? The charge will start moving in the other direction. So, for clearance of the ions, it has time t equal to 0 to t equal to pi by 2. Okay. So, if it is not collected within this time, then they will start moving in the other direction. Okay. So, you know that mobility, what is that? Velocity per unit field strength. Okay. Now, what is the field strength? E0 cos omega t. So, what is the velocity then? You just multiply mobility with that electric field and you get the velocity. Okay. Now, what is the path an electron travels or an ion travels? Okay. So, if you want to find that, then what you do? You integrate v dt. In time t, this much will be the distance it will be traveling. Now, v is a function of time because v is driven by the electric field and this electric field is time dependent. So, you just put that value v is mu E0 cos omega t dt and you integrate from t equal to 0 to t. So, what we want actually? We want now the ions to get cleared within this omega t equal to pi by 2. Okay. So, t equal to pi by 2 omega then. Now, we put that value and if this is the gap of length, this gap of length d, then the electrons or the ions, whatever the charged particle, they need to be collected within that time omega t is equal to pi by 2 or t equal to pi by 2 omega, and they must be able to cross that length. Okay, that length is d. So, so in our case, what is happening? The electrons are getting cleared. So, ion clearance time we want to find. So, this mu I is the mobility of the ions. Okay. Now, the time it is having is t equal to 0 to pi by 2 omega. Okay. So, that omega will tell you the omega max for which the complete charge will be collected in 1 quarter cycle. Right. Now, if it is lesser than that, then they will be definitely collected because after collection also some time will be left. But if it is faster than that, then it will not be collected. So, this omega is giving you the maximum frequency corresponding to which whatever the charge is getting created, they will be collected by the electrode. So, we can do that integration over here and then what we are getting, that d is equal to this integration omega t into dt. So, if you do that integration, it is coming to be mu I is 0 by omega max. So, what is omega max? Mu I is 0 by d. So, this is what we have done there, and corresponding to that, you know that omega equal to 2 pi f. So, we can find the frequency as a max equal to mu I is 0 by 2 pi d. You see over here. So, this was d. So, this is omega. Omega we take this side, that is equal to 2 pi f. So, mu I is 0 by d on this side. So, if you keep it over here, then 2 pi comes down. So, you are getting this expression 2 pi d mu I is 0 by 2 pi d. So, this is the maximum frequency of the electric field which will allow you the ions whichever is created during the breakdown mechanism will get collected by the electrode, respective electrode. So, ions, so it will be collected by the negative electrode. So, now we are finding that this is the maximum frequency, and for if you freeze the frequency, then the maximum distance between the electrodes which should be there, that is given by this value. Now, you see one thing actually. Suppose the breakdown has taken place and the ion distribution is like this, and this is happened at omega t equal to 0. Then omega t equal to pi by 4 is here, omega t equal to pi by 2 is here. Just look at my cursor. And you know that as the time is proceeding, say omega t equal to pi by 4, t equal to pi by 4 omega, there this has proceeded, this has moved like this. So, this has moved like this, and this much is collected. This tail part has entered into the negative electrode. So, then time is moving, and once upon a time it reaches over here, t equal to pi by 2 omega minus delta. That means that still this positive space charge which was created due to breakdown, that is still moving on the left side. Now, after that actually what is happening, this is becoming positive. Okay. So this is becoming positive, which was negative. The ions were getting collected by that. Now it has become positive. So the direction of movement of this positive charge is now the reverse. So it is now moving on the other direction. So so now how much time it is having before the polarity change? It is now this much total. So how much is this? Earlier it was pi by 2. Now it is not like that. When it is even pi, you see over here, then also it is negative, then 5 pi by 4 it is still negative, and then 3 pi by 2, then it becomes 0. So the time interval it is getting omega is equal to pi by 2 to omega is equal to 3 pi by 2. So it is, instead of pi by 2, what you are getting over here is that it is pi by 2 omega to 3 pi by 2 omega. So this distance is d, it is now having more time. So t equal to 3 pi by 2 omega is the upper limit, and t equal to pi by 2 omega is the lower limit when it started moving in the other direction. So what frequency you are getting now? If you do this integration, then you are getting d equal to 2 pi E0 by omega c. We can just see this integration. It is mu 0 E0, then by omega, because of this integration you are getting over here, and you put the limits, you are getting this value. So we are finally getting omega c is equal to 2 pi f. So this 2 comes this side and 2 cancels. So if you do the proper change of the your terms, then you are getting this fc is equal to mu 0 by pi into d. So the pi is because of frequency f equal to 2 pi, omega equal to 2 pi f. Okay, so that is why this pi is coming. So you are getting this critical frequency for ion clearance. Actually it is now mu I E0 by pi d. So earlier it was mu I E0 by 2 pi d. So it was in quarter cycle, but actually what we are seeing that even though it is not clear in quarter cycle, next time it is getting a chance of half the cycle, complete half cycle, to get cleared from the discharge zone. So if it is the charge is getting created over here, then before taking this much of time, it is now getting cleared. So if the frequency is like this, mu I E0 by pi d, then before the next breakdown takes place, you see that the complete charge has been cleared. Okay, the complete charge has been cleared before the next breakdown takes place. So whenever the next breakdown is going to happen, it is not getting any additional assistance due to the charge which was created in the previous breakdown. So the breakdown is as good as the DC breakdown. So that is why you are getting like this, that when the this frequency is low, then what you are seeing that the AC breakdown by DC breakdown, they are almost same. Okay, and as you are increasing the frequency, you are seeing that this AC breakdown voltage by DC breakdown voltage, that is falling. So it means that AC breakdown voltage is less now. Now it is reaching a minimum, and then again it is increasing. You see this graph. Now why it is happening? This is because, as I told you, when the frequency is low, the charge which has been created during the discharge, it is all getting cleared. But as you are increasing, the positive space charge is staying there, not getting cleared, and that is causing you to get additional benefit of electric field due to the charge that has been created, the positive space charge which has been created there and not collected on either electrodes. So that additional positive space charge now assisting you to have additional field which is helping you to get the breakdown. So that is why you are now getting a reduced breakdown voltage, because of the assistance from the positive space charge which was there within the discharge tube. Now when you are increasing the frequency, more and more positive space charge are there, they are not getting cleared. Then a time comes when the electrons are also not able to get cleared even though they are having so high mobility. So at that time, at that high frequency, what is happening? Now electrons are also staying within the tube and not getting cleared. So what is now doing? Earlier you are getting space charge benefit because the positive space charge were creating additional field. Now because of the accumulation of the electrons there, the positive space charge is now reducing because they are getting cancelled by the negative electrons which are not cleared in from the tube because of the very high frequency. So now you keep on increasing, then you will see that a time will come when none of the positive space charge is there, all are neutralized by the electrons. So that time you will see no benefit, of the, this positive space charge, and you will again see that the that breakdown voltage is increasing because the moment the space charge get cancelled because of the very high frequency, the effect of the space charge reduces and you start increasing your breakdown voltage. So that is why this region the breakdown voltage again increasing. So VAC by VDC is increasing, and when you are getting the minimum breakdown voltage, when your this positive space charge is not cleared but your negative space charge is completely clear. So more and more space charge coming into the region of your discharge, they are producing additional electric field and they are helping you to reduce the breakdown voltage. So you reach a minimum and then start increasing because now the electrons are also not getting clear. So a frequency come when none of the electrons nor the ions they are getting cleared. So what is happening? The spaces that is created in the middle, they are moving once that side, one the other side, and they are not getting collected by neither electrodes. So at that time, what is the role of the electrodes? So they don't have any role. So that time you can take the electrodes outside the discharge tube. Then what is happening? You are having a plasma contained within a tube and the electrodes are staying outside, and that is operating at very high frequency. So this kind of discharge where the electrodes are put outside, they are called electrode-less discharge. And this type of discharge has certain benefit that you will not be having any contribution from the electrode contamination. So they will be forming the pure plasma. So this is basically called diffusion. Diffusion and the recombination, they are the mechanism what is now there, the loss mechanism, and that is forming basically a pure plasma kind of thing which can be used for many processing works where you require actually the very pure form of plasma. Okay, so that is the thing, and the critical frequency for the electron clearance will be coming in a similar way, and we will get the same frequency what we achieved for the ions, just we replace the mobility of the ions by mobility of the electrons. So what is there, that F critical frequency FCE for the electrons is mu e E0 by pi d. This is the same as the expression what we obtained for the ions, only the thing is that we have now replaced this mobility of the ions by mobility of the electrons. So that's give you the critical frequency for electron clearance. So with this we now get the understanding of the fact that how the AC breakdown mechanism works, and we have come to know that as we increase the frequency, that assists the breakdown due to accumulation of the positive space charge, but if we increase the frequency further, electrons also start staying inside the discharge tube, that cancels the positive space charge effect. That's why the discharge breakdown voltage increases. And finally what we get actually, we get that a frequency comes when we can take out the electrodes, none of your ions or electrons are getting collected. So a discharge which is called electrodeless discharge, where we get a pure form of plasma, which is contained within the tube, and the electrodes are staying outside. In this plasma, there is no contamination from the electrode. So, if we want to do some processing, which is very pure form of plasma, where very pure form of plasma is required, then we can go for this kind of discharge. So, with this I stop here, and in the next class we will be starting with the plasma sources. Thank you.